Alright, so here we have a new section 7.7. Now I know some of you are a little scared because you said, well wait, we were doing chapter 2 material, 2.1, 2.2. Well, 7.7 is on your first unit test. This has to deal with proportions, or some people call them ratios, and for some reason the book puts this near the back. We're bringing it forward because we just finished talking about solving equations, and proportions is really about solving equations. They're just going to look like they're fractions. So we're doing 7.7, so don't let that scare you that the numbers seem off. It is still going to be on your first unit test. The question is, then, what is a proportion? A proportion is an equation, because for a proportion, you must have an equal sign. Yeah, that's a must. And then what you usually have is a fraction on the left-hand side and a fraction on the right-hand side, usually. So an example of a fraction, let me grab this from my sheet, would be 10b equals 2 33rds. This is a proportion because we have the right-hand side a fraction, we have our equal sign, and the left-hand side is written as a fraction. So this would be also known as our ratio. Now some of you might be saying, well, it kind of looks like the questions that we had before. Some of you might have said, well, doesn't this kind of look like if you had a over 4 equals 5? Doesn't that kind of look like this? The only difference is, one, this wasn't a fraction, but we know how to make this a fraction by putting over 1. Now some of you said, well, you already taught us this. You said that if you have this, you can put in a 1 on top, move the variable over, and then what we could have done is just do the reciprocal, which instead of 1/4, we would do each side 4 over 1. And then our answer would be 4 cancels as 4, 1 cancels as 1, you get A equals 20 over 1, or just 20. Now some of you might be saying, okay, then why can't I do that? Why can't I just put the B over here and make it 10B? Look at the difference. See how the variable here is on top? We were allowed to slide the A over. But when your variable is not on top, but at the bottom, we can't slide the B over. Right? Also, with proportions, you might have more than one letter. You might have a letter here, and you might have a letter here. You might have more corners that have letters. So proportions are better to work with because they can be used for any type of problem, no matter where the variable is. Versus here, the method that we talked about only works if the variable's on top. You'll know when we have proportion problems is because they're going to be a little bit separated from the original questions. So now that we know proportions are a little bit different than the other guys, remember, sometimes the variable is at the bottom, how do we solve a proportion? Once you have the definition, fraction on the left, fraction on the right, and an equal sign, the book tells you you can do something called cross products. Cross, not across, but cross products. You might be saying, wait, what's the difference between across and cross? Cross, think of it like an X. Across with an A just means like top was top, or bottom was bottom. Cross means that we're going to do like an X. Product, we already know, means the answer to a multiplication. So what we're going to do is multiply going like an X. What I usually tell people, instead of saying cross products, I usually tell people, think of butterfly wings. What you're going to do is you're going to take this top corner and it's going to go with this bottom corner. And this top corner will go down to this bottom corner. That way you have that X symbol. So if I loop them, this with this, and this with this, then if I just draw two antennas, it looks like a butterfly. So anytime you hear me talk about proportions, say to yourself, draw that butterfly. Draw those wings going diagonal. That way you know what two items you need to multiply. Now remember, product. Product means we have to do multiplication. So in math, we like to use the parentheses in algebra. Okay, so we're always going to use parentheses to show multiplication. We don't like the dot or the X because that could look like a variable or that could look like a decimal point. We prefer using parentheses. How do I use parentheses to rewrite? Each corner you're going to separate with a set of parentheses. So it's going to be 10, separate in parentheses, with the 33. Must equal the other wing, which would be 2 and the B. Now some of you might be saying, well, why did I do 10 and 33? Is there anything that says I have to do this wing first? No. We could have had this wing done first and then this over here. For some reason, every time I start with this upper left corner, I always start as this side and then the other wing is the other side. Remember, with multiplication, it doesn't matter what order you have it in. So some of you said, wait, does it matter if I put the 2 first, then the B? Or could I do B first, then the 2? Remember, 3 times 8, or 8 times 3, you get 24. So it doesn't matter what order. As long as these two items went together, and these two items went together. Now you might be saying, okay, what is the whole purpose of cross products? Notice, our problem has no fraction bars in it. When you have a proportion and you do those butterfly wings, you don't have to work with fractions. And I know a lot of us hate dealing with fractions. So this is a good tool to have in the back of your pocket, as long as you know how to use this. You got to make sure that there's an equal sign in your problem. You cannot do this if you're doing 7/8 times, and I'll do one of these because this is arithmetic. Let's say we had 14, 49. You cannot do 14 times 8. Because this is not an equal sign, you know that you have to multiply across, top with top, or bottom with bottom. Do not draw a butterfly with this, because there's no equal sign here. You can do something called cross-canceling. That's different than cross-products. So I know some of you say, well, I know 7 can go into 49 7 times, and I know 8 and 14, you can do 2 on each. Right? But this is not multiplication. This is technically like a division. Usually I tell people when we do multiplication, I don't like cross-canceling. I like to do the factoring method. I like to say, can I break down 7 any further? No. Can I break down 8 any further? 2 times 2 times 2. This is known as prime factorization. And then 14 is 2 times 7. And then 49 is 7 times 7. And in that way, when you do the multiplication or cross-canceling, as long as you see 1 on top that matches 1 on the bottom, you can cancel. So a 7 and a 7, 7 and a 7, a 2 and a 2, so that you can get this down to 1/4. This was just a side note, just to realize that this is not a proportion. You have to have an equal sign. Once you realize that you have an equal sign, did the butterfly wings, now you can solve it. How do you solve an equation? We just did it in 2-1 and 2-2. Remember, here's your equal sign. You have a left-hand side and a right-hand side. Now what you're going to do is you're going to distribute. So when you distribute, to get rid of the parentheses, 10 times 33 is 310. Right? And then, do we have any like terms? No. We're done simplifying this side. Over here, get rid of the parentheses by distributing. 2 times b, 2b. Coefficient, variable, no like terms here, done simplifying. Next, labeling. This is the variable side. This is the constant side. So then what you're going to do, move. Constant on the constant side, variable on the variable side. Just got to get rid of coefficient. We don't move coefficients, we divorce. So our last step is divide. And when you divide both sides by 2, divide this, you know this is going to be 165. Here we solved it without really having to work with fractions, even though the original problem was a fraction. That's what's good about proportions, getting rid of fractions so that we can solve it like a regular equation.